Hi everybody, my name is Tiana Keith and today we are talking about a Spearman R. So today's video is going to show you how to solve a Spearman R without using SPSS. We're going to look at how to check for significance and we're going to look at how to write out what our results mean. So, what is a Spearman R? A Spearman R is similar to a Pearson R, meaning that it is a correlation coefficient. So because the Spearman R is a correlation coefficient, that means it tells us about the correlation, relationship, association, etc. between two variables. And this correlation coefficient is going to tell us about the strength and direction of that relationship. So what do we need to solve for a Spearman R? So first we're going to need our formula for how to solve for a Spearman R. And if that looks super intimidating, don't even worry about it. As we go through the problem, we're just going to find the values for those and plug those in, and then we're just going to solve it like a regular math problem. So even though the formula may look a little scary, I promise it's really not that bad. And hopefully you'll see that as we kind of go through this video. So we're also going to need our variables, and that's going to help us with writing what our results mean. And we are also going to need table F from the textbook, and that's going to tell us our critical values for when we're determining significance. So if you don't have access to the textbook right now, that's no problem. I have an image that's going to pop up later of that table, so we can go ahead and use that if you don't have access to the textbook. So let's go ahead and look at an example problem. A group of 12 college students are randomly selected and given a literacy test. Each student is then rank ordered by how many hours they spend on their phone. Test the hypothesis that there is a correlation between literacy scores and hours spent on the phone. Okay, so before we begin, there's always a few things that I like to gather that kind of just helps me keep my information a little bit organized. So first off is going to be that formula for Spearman R that we looked at a little bit ago. And I always like to keep a table handy of all the information that I am going to need. It just kind of helps me to keep organized and not overanalyze the word problem. So sometimes word problems can be really long and lengthy, and you're not really sure what information you would pull and what information you need and what information you don't. So I always like to create a table like this that kind of pulls things from the formula, and then that way I don't have to overanalyze the problem and pull stuff that I don't need and things like that. So just kind of keeps me a little bit clearer as to what exactly it is that I need. So we can go ahead and use this table and pull some stuff from the example problem. So for our first variable, we've got the literacy test or the literacy score on the literacy test, sorry. And for our second variable, we are going to have hours on the phone, and then we can go ahead and find our n value, which is the number of people in our study, which is 12. So that's all that we can gather from the example problem. So let's go ahead and look at our data table. Okay, so we're going to go ahead and pull up that little table that I just mentioned here. And so you can see we've got our literacy scores on the left and we've got our hours already ranked on the right. So the way that these were ranked is that a rank of 1 was the highest amount of time spent on the phone, and the rank of 2 was the second highest, and so on and so on. So what we're going to need to do is we're going to need to rank the literacy scores from highest to lowest. So we're going to start with the highest score, and we are going to assign it a rank of 1, and that's going to go in this column right here. So our highest literacy score is right here. So that is the score of 99. So we're going to go ahead and assign that a rank of 1. And then we are going to basically just continue this process. So we're going to find the next highest score and assign that a rank of 2. So the next highest score is down at the bottom, down here, and that's a score of 93. So we're going to go ahead and assign that 93 a rank of 2. Okay, and then we're just going to continue this process. So if you look at our next highest scores, that is a score of 88, and there's 3 spots that have that score. So when we run into this issue of multiple tied scores, so the scores are the same for different ranks, all that we have to do is take the ranks that we would have assigned them, add those up, and then divide them by how many ranks we have. So if we look at our literacy score, we have 3 different spots that have a score of 88. So we have one here, and then we have one here, and then we have one here. So these would normally be ranks 3 and 4 and 5. And so if you look over to the right, I've gone ahead and added those up. So you add up ranks 3, rank 4, and rank 5, which gives us 12. Then we're going to divide 12 by how many ranks we have. So we had 3 ranks, so we're going to divide 12 by 3, and that's going to give us a 4. And so then what we're going to do is we are going to assign each of those scores of an 88 a rank of 4. So we're going to put a 4 here, we're going to put a 4 here, and then we're going to put a 4 here. And then we just continue the process and we pick up right where we left off. But instead of assigning the next rank of 5, we need to assign a rank of 6 because each of these ranks of 4 took up a spot. So it would have been ranks 3, 4, and 5. So we need to pick up where we left off, which would be rank 6. So our next highest would have been a score of 82, and that's going to get a rank of 6. And we're just going to keep doing this process until everything is all filled out. So I went ahead and put all of the ranks in, and so now that those are done, we don't need to look at the literacy scores anymore. We can just ignore that whole entire column. So next, we need to look at the difference between ranks. So all that we have to do for this is just subtract across the row. So this information here, this is all one row. So we are just going to take 1 subtracted 12, and then that's going to give us a negative 11. We're going to take 11 and subtract 3. That's going to give us 8. We're going to take 4 and subtract 7. That's going to give us a negative 3, and so on and so on. Okay, so I went ahead and did that as well. So now we can ignore all of those other ranks, or sorry, all of those other columns. Okay, so next we are going to focus on the difference squared column. So all that we need to do for that is square what we had found from the subtraction in the previous step. So for the first row, we're going to take a negative 11 and square that. We're going to take an 8 and square that. And we're going to take a negative 3 and square that, and so on and so on. And we're doing this to get rid of those negatives. So you can see here in the d squared column, I've got a 121, 64, and 9. And then we're just going to go ahead and do the rest of those as well. Okay? So I went ahead and squared all of these. And then the next thing that we're going to do with all of that is we're just going to add all those up. So we're going to take everything in the d squared column and add that up, and that is going to give us this right here. That is going to give us the sum of d squared. So when we add all of these together, we're going to get 474.5, and we can go ahead and put that right here. Okay, so there's one part of our problem that is solved. Okay, so now we have everything that we need for the formula itself, so we can go ahead and plug in some of those values to go ahead and solve the problem. So I've gone ahead and done that, and so that's what our problem looks like. So it's a lot simpler than what it initially looked like. And so then we're just going to go ahead and we're just going to solve just step by step. And I've gone ahead and done that. If you feel that you need to slow down the video to see what's going on, please go ahead and pause it at any time. But basically all that I'm doing is just going through and solving it step by step. So it's important at this part here, I put a little asterisk here because you need to round at this point in the equation. Now you have to make sure that you round to 2 decimal places. So our original value for this was 1.65909, and so I rounded that to 1.66, and then I just subtracted it from 1. So that means that our Spearman value is negative 0.66. And then we can go ahead and pop that up right here. Okay, and then that's what we need for our Spearman R. So now we can go ahead and check for significance, and we can write out what those results mean. Okay, So now that we have everything together, we can use the Spearman R critical value table to determine if our results are significant or not. Just a little thing to note, Spearman does not have degrees of freedom, which normally go right here. So we use the pairs of people in our study. So that would have been 12. Okay, so 12 is going to go here and here. And then we're going to look over to the right at table F, and we're going to go down to the value of 12. And then all that we have to do is plug in our 0.01 and 0.05 value. So for 0.01, we have a value of 0.735, and that's going to go over here. And then we've got, for our 0.05, we've got a value of 0.588, and then that's going to go over here. Okay, so now that we have those critical values, we can go ahead and use those to determine our significance. So just a little side note, whatever sign your Spearman value is, your critical values need to match as well. So because we have a negative Spearman value, our critical values need to be negative as well. And you just need to make sure that the signs match, because otherwise your interpretations are going to be way off. So I went ahead and turned that 0.588 and 0.735 into negative values, so we can go ahead and do that. So let's go ahead and check for significance. So is our Spearman value of negative 0.66 greater than negative 0.588? And yes, it is. So that means that we get to reject HO, and we get to do that at the 0.05 level. So although we've gone ahead and found out that we were able to reject the HO and reject that null hypothesis at the 0.05 level, we still need to check for that 0.01 level. So we can just continue to do that using the same process. So is negative 0.66 greater than negative 0.735? And no, it is not. So that means that at the 0.01 level, we need to accept HO. So another way that you can do this is to go ahead and plot your critical values and your Spearman value on a number line. And I've gone ahead and created a number line down at the bottom. And so we've got 0 on the right and then -1 on the left, because we are dealing with negative numbers. And if it was positive, it would just be the opposite. So it would look just like a regular normal number line. So, I mean, and this still looks like a normal number line, but since it's negative, it's going a little backwards. So anyways, okay, so let's go ahead and plot those critical values. So we've got a negative 0.588 somewhere in the middle of 0 and -1. And then we've got negative 0.735 a little bit closer to that -1. So anything in this green area here is going to be the reject at the 0.05 level. And then anything over here in this red area is going to be reject at the 0.01 level. And anything to the right of the green and red area is going to be our accept level. So all that we have to do is put our Spearman value on this number line, and that will tell us where we either accept or reject. And we can put that right here in between the negative 0.588 and the negative 0.735, because that's where that would go on a number line. And that just tells us that we can reject at the 0.05 level. Okay, so now that we know that we are able to reject at the 0.05, that means that we need to interpret our results. We need to write out some kind of sentence or explanation telling us what that number means. And I've gone ahead and created a template that you can use when you calculate a Spearman correlation. And so all that you would have to do is basically just plug in your variables, and you can circle the other parts of this. So like the strong and moderate, you would just circle whichever one corresponds to your Spearman that you found, and if it's a positive or negative relationship. So before going and doing that, let's look at our Spearman value again. So we have a negative value, and just to kind of refresh, we have a negative correlation for our Spearman value. So that just basically means as one variable decreases, the other variable increases. And that can be vice versa too. So variable 1 could increase and variable 2 could decrease. So it's just up to you how you feel like interpreting it. So when we go to our template, we've got a Spearman rank order correlation was ran to determine the relationship between variable 1 and variable 2, and you would just plug those values into that. Looking at our Spearman, we have a strong correlation of a zero point 0.6, so we would just circle that. We just talked that it was a negative relationship, and then we would go ahead and plug in our values. So we have our in value that would go right after that Spearman symbol, and then we would put the Spearman value there, and then the p value after that as well. And then we would follow that with meaning that as variable 1 increases or decreases, variable 2 increases or decreases. And this, you can interpret this however it is easier for you to understand. So if it makes more sense that as variable 1 increases, variable 2 decreases, then write it out that way. But if it makes more sense to you to have it the other way, then you can interpret it that way too. So it's just up to you however you want to interpret it, as long as one of your variables goes one direction and the other variable goes the other direction, it really doesn't matter. So for my intents and purposes, I put that variable 1 increases and variable 2 decreases. Okay, so if we plug everything in and put in the things that we circled, this is what our final sentence should look like. So it would say a Spearman rank order correlation was ran to determine the relationship between literacy score and hours spent on the phone. There was a strong negative correlation between literacy score and hours spent on the phone, which was statistically significant. And then you would put your Spearman degrees of freedom there, the Spearman value that we found, and then we did reject at the 0.05 level, meaning that as literacy scores increased, time spent on the phone decreased. Okay, so for our problem that we did, we were able to reject. But if for whatever reason you come across a problem where you are not able to reject HO and you have to accept and basically state that there is not a difference between your two variables, here's another template that you can use. And you're going to use the same formatting as before. It's going to be a lot simpler. So all you need to do is just plug in what variable 1 is and what variable 2 is. And so your final result is going to say there was no significant difference between literacy score and hours spent on the phone, or no significant difference was found between literacy score and hours spent on the phone. Okay, so that is the end of the video. Congratulations, you made it, and I hope that this helped.